Hello, my name is Valentin Tachukin. I am an IPCS specialist of the IPCT company. IPCT is a partner of the famous Taiwanese manufacturer ICP, which does automation equipment. In this video review, I will talk about the functionality and features of the TPD and VPD series input and output panels from the manufacturer ICP. Also, I'll show you how to program these panels in C and water diagram. ICP provides two types of touch HMI devices, the TPD series and the VPD series. The TPD series is designed for home and building automation applications, and the VPD series is designed for factory machine automation applications. Both have many common features, such as a high-resolution touchscreen and a variety of communication interfaces. However, each still has its own specific features for its respective target applications. For the TPD series, you can use an external wall box to help you blend the TPD series device into your decoration. For the VPD series, the rubber keypad, IP65 waterproof front panel and the DIN rail mounting are designed for harsh environment and are especially suitable for factories. For monitoring and control, the panels could be used with the i7000, M7000, ET7000 modules from ICP and with Modbus wave devices from any third-party manufacturer. Manage lighting, ventilation, heating, the list goes on. Depending on the model, the panels use either RS485, either Ethernet as their communication interface, allowing data exchange using Modbus RTU, Modbus TCP, and DCON protocols. There are models with additional flash memory, allowing to increase the number of simultaneously displayed visual objects. Some models have a real-time clock and a USB port for you to easily upload your projects into the panel. Depending on the model, the panels are powered either at a constant voltage of 10 to 30 volts, either through the network cables via the POEM architecture. The TPD series are mounted on a wall or in a specially designed for that box. The VPD panels are mounted in the panel or on a DIN rail and have IP65 protection on the front panel. In addition, the panels VPD132 and VPD133 are available with an option of installing discrete in and out expansion boards. A distinctive feature of the VPD130 are 5 programmable keys on the front panel. Now let's program these panels. I'll show you how simple it is to organize a survey of the M7055D module. The module has 8 digital inputs and 8 discrete outputs. It works on the Modbus RTU protocol. As previously noted, TPD and VPD operator panels are programmed in C and water diagram. To do that, the HMIWorks program will be used. Create a new project, File New. Now let's call it Demo version 1. Choose our device, language, water. Choose the water diagram language, click OK. We created a new project and the screen frame 1 appeared. This is the screen that will be displayed on our panel. Now about the HMIWorks interface. On the left, you can see the Workspace tab. Here you can set up connection, connect a new device, add some new tags. In the Toolbox tab, the user can select objects and widgets for the operator interface. On the right is the Inspector tab. Here you can configure the current object. For example, we select frame 1 and we can change the background color. The Libraries tab contains various graphic elements, flashing lights, buttons, and indicators. We will now create a project we will use to control the M7055D module through the operator panel. Click on the connection with the right key and create a new connection. The name is COM1_1. The interface is COM1. The speed is 960. The module is configured just for this speed. Click OK. We have our connection displayed on the left. Now we can connect the device itself. Create it in our program. Right-click on Device, New Device. In the new window, select the Modbus RTU protocol, Series M7000 COM1 connection. Choose our model from the list, M7055. There are tags that are automatically attached to the discrete inputs and outputs. Net ID is the network address of our device. In this case, the module has the first address. Click OK. We see that our device appeared in the program with all the tags. Next, we'll link the tags we need to the images. To do this, we select the image of the button on the right side of the screen in the Library section. At the same time, on the left, we select the text with which we want to associate the button, for example, the discrete output of the 0 channel. I just drag the tag to our workspace, and there we have the button image. I do the same with the other discrete outputs. Buttons can be aligned by selecting the Layout tab and finding Align Vertical Center there. We add 4 more buttons. Just align them. Next, create an indicator that shows a disconnection. Let's choose light S. S means a small image, M means a bigger one. Select the image and associate it with the error tag. You don't need to create anything else here. The project is ready. It is necessary to compile the program. To do this, select the Run tab and select the Build and Rendering options. The project was compiled. Now we need to upload it into the operator panel. To do this, move the switch on the panel to position 9. This is the mode for downloading the program. We click on the Reset button on the same panel. Then, we upload the program into the panel. Click Run, Download Only. Our project was uploaded without errors and is displayed on the screen. Now we can manage the M7055D module. Also, the error indicator is working just as intended. Next, I'll show you how to program the panel in the C language. By pressing the keys on the front panel, we will operate the discrete M7055D module. To do this, create a new frame. In the Layout tab, New Frame. Select the C language. In order to understand whenever the key is pressed or not, we need to pause the timer. In the Toolbox tab, select the timer and move it into our workspace. Set the polling interval to 100 milliseconds. Go to the C language editor. To do this, double-click on the timer image. Since I've already written the program, I will simply copy and paste it into this window. The program is very simple. In this area, we count the key code and write it into the variable. Next, we determine what kind of keys are these. If this is the first button, we set the logical unit on the 0 discrete output of the M7055D module, and so on. Click OK. In order to switch from frame 1 to frame 2, we use a special button. The button will be an element on the graphical user interface. I will transfer the images of the arrows from the library to frame 1 and frame 2. Also, we need the hotspot widget. This widget allows you to easily configure the transition from one frame to another. In the inspector box, set the reference parameters to the link with frame 2. Also, on frame 2 we put the hotspot widget and set the reference parameters to the link with frame 1. The project is now configured. We compile it and upload it into the panel. The project is finished, and now we can press the keys to control the discrete outputs of the M7055D module.